All right, so we were just looking at the types of roots we have. We can know the kinds of roots that we're going to have by looking at the quadratic formula. Remember, the quadratic formula had that part in it where we had a square root. We had the square root of b squared minus 4ac. Well, the thing about a square root is that I'm allowed to square root 0. I'm allowed to square root positive numbers, even numbers like 2, even though that doesn't have a perfect square root, I'm still allowed to do it. What I can't do is take the square root of a negative number. Square root of negative 4, for example, that's like saying, what times what is negative 4? Well, there's no way to multiply the same number by itself and get a negative, because a negative by a negative becomes positive. So it's not possible to ever create this. So this helps tell us how many roots there are. If the b squared minus 4ac is negative, then I have no real roots. They're imaginary. I have no zeros. I do not cross the x-axis. If, however, it's positive, if it's exactly equal to 0, think about the quadratic formula. It said negative b over 2a plus or minus. We can use this symbol for the discriminant. So plus or minus the square root of the b squared minus 4ac over 2a. Well, if this is 0, all I end up with is negative b over 2a plus 0, still negative b over 2a, or negative b over 2a minus 0, still negative b over 2a. That's when I have one real root, and this is why I called it repeated. Because we have two equations, we have a plus or minus, it's just that we're plus or minusing 0. Two unequal roots is if this is a positive number. So if my discriminant is positive. So we've got negative, equal to 0, or positive. So in the next video, we're going to apply that to determine the number of roots these different equations would have. And again, b squared minus 4ac is called the discriminant, and we use this symbol, this delta symbol, for the discriminant.